This tally stick goes back 30,000 years ago. We're pretty sure the last tally stick, and others were numbers markings. The others may be, and push such theater-level understandings of numbers back far indeed. Here's a picture of the famous cave paintings. I include a picture of a hand because it shows awareness of oneself. Jacob said at the end of the first episode of his Ascent of Man, about the cave paintings, man said I have power, but what power? He's saying the people that made the cave paintings were trying to exercise a kind of magic. This idea of magic reminds me of how hunter-gatherers would wear the skull of the animal they killed, and even the hide. They felt powerful in doing so. The cave painters probably felt much the same way by drawing the animals they lived by. As Jacob Bronowski said, man says he has power, but what power? What I find in Sir James Fraser's Golden Bough is that much of magic is evasive logic. I found this one passage, in, of all places, The Ancient Engineers by L. Sprague de Camp. People swarm everywhere, talking of incomprehensible matters, in hovels, streets and square, marketplaces, and crossroads. When I ask how many oboloi I have to pay, they answer with hair-splitting arguments about the born and the unborn. If I inquire the price of bread, I am told that the Father is greater than the Son. I call a servant to tell me whether my bath is ready, he rejoins that the sun was created out of nothing. The difference between magic and mathematics is one is constructive, the other evasive. I always considered the cave paintings as before humanity was conscious of astronomical things. But recently, the dots on the cave paintings' animals have been shown to correspond to the seasonal patterns of animals' movements and when they give birth. More proof of humanity being conscious of astronomical things back in caveman days is Göbekli Tepe. What really nails the case that humans were conscious of things astronomical back then is Karahan Tepe on the left side. As you're viewing it here, you can see a rectangular hole that allows a beam of light to enter the circular temple inside. Göbekli Tepe and a dozen similar sites like Karahan Tepe called into question when agricultural civilization began. It took them a while to prove it, but they found a site before Göbekli Tepe that proves Göbekli Tepe and associated sites were the beginning of agricultural civilization Çakmaktepe. The transition from hunter-gatherer to agricultural civilization is one of archaeology's and science's biggest mysteries. The leap from hunter-gatherer to agricultural civilization is as big a leap as figuring out the Earth is round from our flat Earth perspective. This leap highlights my points about how knowledge works that I introduce above. Kind of like being able to see the simple pattern in a waterfall that otherwise looks like chaos, the hunter-gatherers had to go from wandering around with the animals to trusting the science and technology of agricultural civilization. This following of the movements of animals was seasonal, or astronomical. As of writing this, archaeologists have shown the dots markings on the cave paintings were number of months that animals moved from location to location and gave birth. Plants follow the movement of the sun across the sky, like the sunflower. The blossom at the right temperature. Animals hibernate. There's even recent evidence that Neanderthals hibernated. They move to certain mating grounds based on the seasons, and give birth seasonally. And, the hunter-gatherer Homo sapiens followed them. Homo sapiens were as mechanically linked to the changing seasons as the animals were. And, to overcome this was a conceptual leap of the kind described above, of going from our flat Earth perspective to figuring out the Earth as a sphere. Homo sapiens had to wait for the last glacial event to retreat around 21,000 years ago. Then, we find in the Levant, the ruins of Ohala II. Ohala II dates to 20,000 years ago, and has much wild rice collected. Ohala is considered a hunter-gatherer site. People would wander from temporary site to temporary site. And, in Ohala II, they'd collect seeds, and plant them. From the Kebran culture, which Ohala II is part of to Natufian, the animal bones and the plant remains went from wild plants and animal bones to domesticated. The flintstone technology in use for millions of years changed to small curved sickles. The sickle blades would later evolve into the plow to farm in harder-to-farm areas. The transition from hunter-gatherer to agricultural civilization stimulated mathematics for sure. The Greeks considered the Egyptians as the originators of mathematics. This certainly isn't true, but we start with them first. When we get to the Egyptians, we see base 10 arithmetic. For tens of thousands of years, mankind evolved from base 2 to the Egyptian base 10, and the Babylonian base 60. The Egyptians had separate symbols for 1, 10, 100, and 1000. They would also represent 3 as 3, and 7 as E. We can see the theater example of number above in Egyptian numbers. Each symbol for 10, 100, and 1000 is like the theater example above. One can see a theater understanding of Egyptian fractions as well. They had a separate symbol for 1/2, 1.3, 2.3, 1/4, and 3/4 to get to other fractions. They did a kind of fractions algebra. Kind of like how in algebra you can substitute a whole expression for a single letter in another equation, the Egyptians would substitute a fraction that equals a certain number or even fraction in another expression that had that number. For instance, 1/3 equals 1/6 plus 1/6, and if they saw 1/3 in another mathematical expression, they would substitute 1/6 plus 1/6 for 1/3. They also considered 1/2 as the definition of dividing something in half. So, they'd substitute 1/2 for something they want to divide in half. A great example is duplication of fractions. Egyptians considered duplication multiplication. Duplication is multiplication, but you can't understand 2 times 3, or 3 times 5 from there. For them, 2 plus 2 equals 2 times 2. For instance, 12 times 12 is done by doubling 12. 1 to 12, 2 to 24, till you get 4 to 48 and 8 to 96, and then adding the last 2 to get 144. Just like in 2 plus 2 equals 2 times 2, they multiplied 12 times 12. They generalized this to fractions. For instance, 1/3 plus 1/3 equals 1/2 equals 1/6, or, in 3/6 plus 1/6 equals 4/6 equals 2/3. If we divide by 3, 5, or multiply by 1/3, 1/5, we get 1/9 plus 1/9 equals 1/6 plus 1/18, and 1/15 plus 1/15 equals 1/10 plus 1/30. One could double unit fractions easily enough. If you have say 1/9 plus 1/9, just add 2 more for 1/9 plus 1/9 plus 1/9 plus 1/9. This can clearly get cumbersome. If you wanted to double the last expression, you'd get 8 1/9ths. Then double again and so on. So the Egyptians did the above adding is duplicating trick, 1, 9 and a sixth plus 1, 18 and a third plus 1, 9 and 2/3 plus 1.6 plus 1/18. When they got to the third line, they substituted 1/6 plus 1/18 for 1/9 to get 2/3 plus 1/6 equals 1/18.